Our next speaker has been on the MongoDB core engineering team since 2010. He's held former roles focusing on bioinformatics and operating systems. Please welcome the VP of Global Services for MongoDB, Richard Kreuter.
Thank you, Eric, and good afternoon, everybody. Thank you for spending a beautiful summer afternoon learning about databases. I am, in fact, Richard from MongoDB, the head of professional services for the MongoDB company. So I represent the part of that company, of my company, that involves consulting and training and working closely with customers to make sure that they're successful with the use of our technology. And so very often, when I come give talks different places about MongoDB, it's to tell you how to solve some particular problem using MongoDB's technology. Eric asked for a brand new talk, and I'm actually a little tired of telling people how to solve problem X with technology Y. So today I'm here to talk to you about a few things that some of the most interesting use cases from some of our customers and users out there of how they're applying MongoDB to solve the problems that they want to solve. But before I do that, I would like to make a couple of observations, certainly from my perspective, from the MongoDB perspective, about data and applications. And this is probably stuff that, if you're a practitioner working today, is already commonplace for you, but just to emphasize a few ideas and the way that we see things. On the one hand, I think everyone would agree that the volumes of data, just the sheer number of bytes of data that we're trying to handle nowadays, far outstrips anything imaginable at the outset of the computing industry, right? Even just 15 years ago when I got into this game, the kinds of data volumes that we were dealing with were many orders of magnitude smaller than what people are working with nowadays. On the other hand, as the previous speaker talked about, the requirements of always-on applications are pretty intense, and so the need to have databases and the systems built on top of databases that are on 24/7 because it's always business hours somewhere, or at least it's always time for people on social media websites to be communicating with each other, is a real novelty in the last 10-ish, 15-ish years that really forces some different kind of handling of data processing, computation. And of course, another thing that becomes possible with the kind of always interconnected world that we live in, of human beings and devices and sensors and machines, is that there's all kinds of data out there that maybe in conjunction with each other actually uncovers and reveals interesting patterns out in the world that are very hard to see when the data is siloed, but become more visible when the data is aggregated. And so these are all sorts of considerations about the volumes and rate of change of data that we're dealing with today, the data types that we're dealing with today, what people want to do with the data today, that really motivated the development of MongoDB, the technology, and the founding of the company now called MongoDB. So just to give you a sense of who and what we are, if you're not already familiar with the technology in the company, MongoDB, the company, was founded about 9 years ago, actually just a couple miles away in New York, with the goal of building a modern sort of database for the modern volumes of data that people have, and in a way that fits, we like to think, rather naturally into the way that people want to develop applications today. The founders of the company were sort of startup people. They had about 10 companies behind them, and they found in their previous companies, no matter what the problem space was, the same pattern at the data layer, which was starting with off-the-shelf database technologies, doesn't matter what kind, and then rapidly reaching the limitations, or at least pushing the boundaries of those technologies, whether that was because of the data volume or the speed at which the data needed to be ingested, or the requirements for keeping those databases online all the time, the kinds of things that required offline maintenance versus the kinds of things that could be performed online, or simply the desire to commingle data coming from different upstream data sources in a way that was challenging, to say the least, with legacy technologies. And so, the company got started. I've actually been with MongoDB, as Eric mentioned, since 2010, so I've seen much of the history of the company. And I'd like to humbly say that we've seen a certain amount of success. Nowadays, MongoDB, the company, can boast more than 2,000 paying customers, including more than half the Fortune 100 companies. Over 50,000 members of MongoDB user groups all around the world who get together periodically and talk about what they're doing with MongoDB at meetups and conferences and this sort of thing. Over 1,000 partners in the larger ecosystem of people doing things with, around, for MongoDB and the user base. And over 15 million downloads of our core open source database technology, which I'll say more about in a moment. And finally, we've actually developed our own online courseware, which is at MongoDB University, and we've had over 400,000 registrants who've taught themselves MongoDB using our free courses. So there's certainly something here that seems to be striking a chord with people out there in the world. So I'm sure many of you know a bit, or maybe more than a bit, about MongoDB, but I just want to get started by saying that what we think we're doing is actually combining the best attributes of traditional, especially relational databases, with some other ideas, not necessarily new ideas. If you actually are interested in the history of these things, there's very little that is actually new under the sun, so to speak. But we think that combining some of those ideas from the sort of ordinary commodity relational database space with some other ideas gets you something that's actually a difference in kind, not merely a difference in degree. So of particular relevance for the stories that I would like to tell you about today are a few. On the one hand, of course, if you're familiar with relational databases, which everybody is, you'll know that relational database is one of the hallmarks, is having a rich, semantically rich, expressive query language in the form of SQL, along with complementary features that make SQL, efficiently executable, secondary indexes, query optimization, that sort of stuff. MongoDB has exactly analogous features. We have a built-in query language. It's not SQL, but it's very rich and expressive, allows you to say most of the sorts of things you can say in SQL. Arguably, some of the things that you can say in MongoDB's query language are perhaps more understandable or debuggable, perhaps, than what you might say with the most complicated of SQL expressions. And we have the same kinds of secondary indexing and query optimization features built into the database to make our queries run fast, analogous to what you'd expect in a relational database. So in this respect, MongoDB is actually quite a lot closer to what you're probably already familiar with if you've been living your careers with relational databases as I did before I joined MongoDB. Now, one thing to be aware of, especially if you're more familiar with the NoSQL community, so to speak, the ecosystem of NoSQL databases, is that our query language is actually built into our product, whereas in some other solutions, querying and processing the data is usually a separate it can be a separate process, perhaps even a separate solution, independent of how the data is stored. One thing I might mention about our query language is that it's proven sufficiently popular that Microsoft and IBM have both begun introducing products that actually incorporate our query language for the purpose of processing documents in their databases. Now, on the other hand, in the sort of non-relational direction, the key idea, the key sort of defining characteristic, if you've ever played around with MongoDB or used it, is of course that we are a document-oriented database. Now, in MongoDB, the core record structure, the thing that's most closely analogous to a row, is something that we call a document. Not a Word document or a PDF, but a document in the sense of similar to an object in JSON notation, or an object in a programming language. This turns out to be surprisingly, to some extent, a really powerful, desirable feature in a database because it more closely, naturally models the way that people like to think about their entities in their problem space. Certainly, it more closely models the way that you program in an object-oriented programming language. So for example, if your problem space was something to do with people, and in your programming language you have a class called person, and a person has a name, and a phone number, and some hobbies, the way that you would model that in MongoDB might just be a single document for a single person with an attribute for the name, an attribute for the phone number, and then a list embedded inside of the hobbies. Maybe my hobbies are cooking and bicycling, for example. And the nice thing about this is that on the one hand, the documents themselves are about as self-describing as any other nicely structured object that you might write down in any notation, and also that they map very straightforwardly to the object in your programming language, in such a way that you probably don't need any kind of complex mapping layer between the application logic and the database. And because the data is actually stored the way that you describe it within the database itself, the database doesn't perform or need to perform these complex joins that, of course, you have to do when you're modeling your data in a normalized relational database schema. Getting rid of those joins, in turn, allows many, many MongoDB users to drop the caching layer from their application architecture. MongoDB often ends up being fast enough on the query side to dispense with that intervening cache. Finally, for the purposes of the stories that I want to tell you, another key attribute of MongoDB that's been built in from the ground up is our horizontal scaling story. There are some other databases that are horizontally scalable as well. MongoDB builds it into the DNA. Our horizontal scaling architecture happens to be called sharding, and the basic idea is that at any time you can take your MongoDB cluster, add some more resources to it, new machines, new virtual machines, as the case may be. MongoDB will automatically reparcel the data over whatever hardware capacity is available to it, in order to distribute read workloads, write workloads, aggregation workloads, what have you. And in this way, MongoDB clusters can be grown in their throughput capacities automatically, invisibly to the application without any downtime or any application schema changes. Now, there are lots of other things that are interesting to discuss with MongoDB. Perhaps we could talk about them offline if you have some interest. These three, the rich query language that's built into the database and the features that make it efficient, the flexible data model that's implied by having these objects, these structured, nestable objects, as the data model in the database, and the ability to scale the system while it's running, are a few attributes that are particularly exciting for a lot of our users and that actually underpin the stories that I'd like to tell you. Now, when I was thinking about what kind of stories to tell you about interesting things that people might do with MongoDB, you know, there's lots of them. There are certainly lots of business applications, large and small. If you actually want to learn some more use cases about MongoDB, you can find some on our website at mongodb.com, lots of customer and user testimonials from different sorts of events. But I wanted to tell a few that were particularly technically interesting and that really might suggest something about the way that these large volumes and interesting kinds of data uses that I was alluding to earlier might really change, for the better I hope, some things about our future. So one customer of ours is the large manufacturer Bosch. And one of their applications is actually an Internet of Things platform, which itself in turn has many applications for storing large volumes of data for different sorts of purposes. One of the use cases for this IoT platform is actually to store airplane maintenance data. So Bosch's customers presumably are either carriers or their subcontractors who perform airplane maintenance. And what this system does for them is it stores sensor data coming off of the tools that are used to maintain the different assemblages on the airplane, get uploaded into MongoDB and stored there. And so, for example, they might have a screwdriver or electrical screwdriver with various sensors, and the screwdriver itself records the torque being applied to the screw and the position that the screw was left in at the time of maintenance. This information is transmitted wirelessly, cellularly, I'm not really sure, may not matter, and then stored inside a MongoDB database. Now you might wonder, why would it be interesting to store sensor data coming off of electrical tools on an airplane maintenance job? Well, the answer is that this way of storing the data permits an application to be built on top of it, which application exists, that does predictive maintenance analysis. So it analyzes the state of all the screws and all the rivets and all the other gadgets and doohickeys on the airplane that get maintenance for the purpose of tracking which ones are getting more maintenance, which screw on the wing is getting more maintenance than the average for planes of this model. And this allows those carriers to actually optimize for making the maintenance more efficient, figuring out which assemblies might actually need to be modified in the future. Maybe they should use a screw, they should use a rivet, something like that. By looking at this very, very fine-grained, high-volume data about every single piece of bolt and screw that's tightened on the airplane during its regular maintenance. Now, one of the reasons that they selected MongoDB for this IoT platform was, again, because of the horizontal scaling capacity, the ability to grow the MongoDB cluster while it's online, which, of course, permits this system to take on larger and larger volumes of data as more and more carriers and other sorts of people in this space want to ingest data into this predictive maintenance platform. Another reason that they selected MongoDB actually has to do with that flexible data model. This year's devices upload certain data. Maybe next year's devices will upload other kinds of sensor data. The screwdriver this year might record torque and the position of the screw. Next year it might record torque, the position of the screw, and the temperature of the screw. Why might it be interesting to record the temperature of the screw at the time that the maintenance was done? Well, because, you know, materials expand and contract, and that temperature data, if they had it, might allow them to make more efficient decisions about what sort of materials to make the screw out of, what sort of fasteners to use, that sort of thing. All of this tends toward a more intelligent set of decisions about how to do the airplane maintenance, perhaps how to do the airplane design, maybe the screws are in you know, unlucky locations, that sort of thing. All of this tending to make the maintenance more efficient, and therefore presumably make airplane travel safer for us all. So this is a really sort of interesting sort of use case, I think, because, you know, you might not think that such simple things as you know, the tightness of screws in various locations would be something that anybody would bother to be interested in, let alone store, let alone do analytics on. But in fact, it turns out this ends up being something quite interesting to the carriers. Another exciting use case that I actually learned about relatively recently comes out of Nigeria. Now, I've never been to Nigeria. I don't really know a lot about it, but I think for many people, you know, the first thing that comes to mind with Nigeria is a lot of email that you might receive about people suggesting that you might help them get some money out of the bank account. Now, of course, that's, you know, a commonplace stereotype. As it turns out, this company, Mapit, who's a user of MongoDB, decided to apply MongoDB to solving problems actually having to do with how money is circulated within the Nigerian government. The Nigerian government publishes, at various levels, data about public works projects, road construction, bridge construction, tunnels, these sorts of things. But this data comes in lots of different formats and is published by lots of different people in lots of different ways. And what Mapit does is it actually takes those data, which are all public data, but they're coming out of different silos in different formats, and aggregates them together in one place for the purpose of being able to, well, let people do things with that data in a single place. In particular, putting that data into MongoDB, which is a fairly straightforward application of that flexible document-oriented data model I mentioned earlier, allows Mapit to present to the citizens of Nigeria information about how the public works projects are going. Indeed, this is precisely in order to allow the citizens of Nigeria to actually look at the progress of the public works and how the progress is going and where the money is being spent. The very purpose of this is to allow the citizens of the country to actually combat corruption and fraud within public works projects. Another aspect of why people use MongoDB for projects like this is actually a very specific feature that I might as well mention having to do with our featureful query language, which is that MongoDB has built-in geospatial search functionality. And so the data, provided that you build a certain index on it, can be treated as if it were points on a map, latitude and longitude points. And then you can execute queries in the database saying, get me all the points that are within a certain distance of the central point, or get me all the points within a polygon, which might represent a state or a province or a country, or get me all the points that are within a certain distance of any of the points on a polyline, which you might use to model getting all the data within a data set that's nearby a road or a river. And so it becomes possible, therefore very straightforwardly, to have this data in MongoDB, to index on it in a geospatial fashion, and then to do different sorts of user interfaces in front of it, such as map-oriented user interfaces, so that people can actually take a look at what are the public works projects in my city or in my neighborhood. And again, this was all selected by Mapit precisely for the ability to combine those disparate data sets while simultaneously being able to query on them efficiently in order to actually promote this, democratization of understanding of the public works projects. Another really neat example that I learned about recently, use case that I learned about recently, is from a company out of the UK called Oxford Nanopore. Oxford Nanopore actually makes these devices that literally fit in the palm of your hand. I've seen one that can do DNA, real-time DNA sequencing in about 4 or 5 minutes of any organism in the whole of life. Now this one actually sort of struck a chord for me because I actually spent some years, about 10 years ago, actually working in bioinformatics. As it happened, plant DNA at the time, but the principles apply across all of life. And one of the things that I experienced back then that was echoed in my conversations with the folks from Oxford Nanopore is just how, sort of on the one hand, the mental model that you have when you're working with DNA and proteomic data in this space is very simple. The mental model is very simple, but what you have to do to model it in some kinds of databases is very hard. Just coming from my own background when I was working in plant bioinformatics, really what you have in a lot of these applications are these very long strings of DNA sequences. And these are really just strings in the standard programming language sense made up of a very restricted alphabet. On the other hand, you have a lot of metadata about those DNA sequences. The time at which it was obtained, the organism from which it was obtained, the experimental protocol from which it was obtained, perhaps the experimenters who performed the protocol. Other things that you might store or you might find stored would be environmental information, humidity, temperature, these sorts of things, because these can all affect the experimental protocol and the accuracy of the device that's used for doing the DNA sequencing. So you have this string, which you think of as an entity, and you probably have lots and lots of them for a particular organism, or maybe from a particular experimental run that might span organisms. But you have all this metadata, and it really has a very hard schema to understand. In fact, people have gotten PhDs for trying to come up with ontologies of the metadata that applies to this data. So if you ever have spent any time in this space, or even if you haven't, it's an extraordinarily interesting but complicated problem to try to figure out just how should you model the metadata around this scientific information. Now, when I was doing this 10 years ago, I remember thinking, gosh, this is a real pain in the anatomy. You have these DNA sequences, and you have this metadata, but the metadata itself comprises hundreds of tables. They're not large tables, but they're nevertheless extremely complicated in their relationships to each other. This, of course, is in a relational database back in my misspent youth, as it were. All this metadata is extremely complicated in its interrelationships. Really, all you ever want is get me the sequences for some particular slice of this metadata. But those queries become incredibly complicated, given the way that you have to model it in sort of the way it's done. Now, Oxford Nanopore, the folks from there, told us exactly the same kind of story. They said, listen, we're scientists. We need a database that enables us to build our product faster and get it out there and store the data, query the data, and so forth. We don't need to spend years and years figuring out how to model this complex metadata that goes along with the DNA information. And so they selected MongoDB precisely for this reason. The entities in MongoDB are these DNA sequences, along with, in the same document, whatever metadata is relevant for that particular experimental run coming out of this particular gadget at this particular time, in a very straightforward way, while simultaneously being able to do all of those fancy schmancy queries that, in my experience in the relational space, took a join across a dozen tables is a scan, perhaps on a single index out of MongoDB. And so what they told us was that this allowed them to get their product out faster, get the devices out in the hands of people, and actually these devices are now being used all over Central and South America, actually to study the spread of Zika. So this is another sort of fascinating way in which miniaturized and increasingly inexpensive sensors and gadgets out there in the world can produce this large volume of data very quickly. But what you need is a more nimble data store that can store it, that can analyze it, that can query, where you can do your aggregations and your analytics, all on the data in place. So I think these are a few interesting things. I've told you about how people could use MongoDB. Certainly, for some of these kinds of use cases, other technologies would have been appropriate as well. I have a dog in the race, but I'm not unreasonable about those sorts of questions. But on the other hand, I think they say things about ways that some exciting new things could come in the future. Safer airplanes and better public works projects and Star Trek devices doing science in our hands. Now, I'm particularly proud that MongoDB happens to be part of these stories, again, because of the various features that MongoDB happens to bring to bear. But, like I said, some other technologies might have been reasonable to consider as well. Now, if you're more specifically interested in MongoDB, I did mention that I'm only touching on a few of the elements relevant to those stories. Of course, we have, the strong consistency models that you're familiar with from the relational space, along with weaker consistency models that you're probably accustomed to if you're more accustomed to non-relational databases. MongoDB does have, again, built into its DNA, logical replication, permitting for always available and, in fact, globally distributed database deployments. If you happen to be particularly interested in learning more about how to use MongoDB at the detailed level and you want to take a course on it, you can go to university.mongodb.com and sign up for one of our free courses for either developers or administrators. And if you're the sort of person who prefers to roll up their sleeves and actually just get their hands dirty, you can just download MongoDB directly at mongodb.com/downloads. The core database is all open source, and you can get started with it in, well, you'd be surprised, probably 15 minutes. So I just got the 5-minute sign, so we have 5 minutes for any kind of Q&A. Thank you. I suppose I can ask you all a question. Who has already used MongoDB? Oh, so about half. And anybody running it in production? Okay, so a few. And for people who haven't used MongoDB, who's going to maybe try to download it today? Okay, great. Anybody have any questions about any of it, whether you're already in production or not? Yes, sir?
Can it be used for small companies as opposed to the large enterprises?
So the question was, could it be used by small companies as well as large enterprises? Yes, of course. I mentioned Oxford Nanopore. As far as big versus small, you would not consider, I happen to know how many people they have. I don't want to say anything while being recorded that might be considered embarrassing or anything. They would not be considered a large company today. They're a relatively small startup. So yes, it's used by companies big and small. I personally have worked with probably about 300 companies, many of them on the smaller side, just owing to how early I joined MongoDB. Today, a lot of our big stories are from Bosch and other sorts of very large conglomerates and big enterprise type customers. But of course, we use it all scales. Yeah.
I have a question.
Yes, please.
How is do you think that in the next 3 to 5 years demand-supply ratio compared with the SQL?
So, I'm sorry, how do I expect in the next 3 to 5 years the what?
Demand-supply ratio, like SQL and MongoDB.
Oh, I see. So your question is, is it going to be more interesting to be on the SQL side or the non-SQL side in 5 years? So that's a really interesting question. I think a lot of databases are actually beginning to offer very similar overlapping feature sets. The speaker before me was just speaking about Postgres. Postgres is a fantastic relational database. I mean, I know I'm not supposed to call it a relational database according to the previous speaker, but it's a fantastic database in that space. They're adding a lot of features having to do with JSON. MongoDB actually is adding joins. I mean, we've added joins in our most recent release, and there's more relational type functionality coming. We've built a SQL interface as a front end to it. So I suspect that a lot of databases will have overlapping sort of feature sets if all you care about is the features. On the other hand, there's still going to be some things that will be better with some databases than others. Some things will be faster, some things will be easier on one system than another. And so I'm actually a very, sort of practically minded person. I would suggest to evaluate on a problem-by-problem basis what you should do. Of course, I can also tell you how to use MongoDB for any particular problem that you might have at hand if you can, and I'll tell you not to if you can't. So I expect that over the future, there will be a variety of databases out there, and it would probably only be practical for anybody today to familiarize yourselves with each of them. Yeah, how much time do we have? Got 2 more minutes if anyone has any questions. Yes?
So you say you shard the data across different servers?
Yes.
How do you handle if one of the servers goes down?
Sure, so the question has to do with our horizontal scaling strategy, which is called sharding. It's analogous to partitioning in some other databases. And the question was, how does the system handle it if one server goes down? So I only told you one half the story. You could think of sharding, MongoDB sharding, as one dimension. Within each shard, it is recommended that you provision with redundancy. So typically, the minimal number of data-bearing servers you have per partition would be 2. So if one goes down, the other one takes over. And that's based on a replication architecture, which I didn't really go into deeply. Yes, sir.
So, of course, one of the things you talk about MongoDB is that you can be very dynamic and finding records over time and throw things in.
Yes, sir.
Is there any case studies of record structures that work for some type of applications in e-commerce or that are part of university?
Yep. So just for everybody, the question was, are there any case studies or best practices having to do with document schemas for certain kinds of use cases? Is that a fair summary?
Yeah, exactly. And when you're going to be adding objects or anything else to size things.
Yeah. So yeah, we have content in our MongoDB University courses around data modeling. We also have many blog posts about how you solve different sorts of problems, often rather narrowly scoped. We've also got some examples and some white papers on specific kinds of use cases, product catalogs for e-commerce, these sorts of things. So that's sort of an emerging space of getting lots more of these best practices out there. But yeah, I mean, my team, in particular, the consulting team, has lots and lots of experience helping customers with different verticals and sort of how their problems tend to go. But it's often actually a lot easier than you might expect. Okay, I think I'm out of time, so I apologize, but thank you again for coming out on this fine afternoon.